So looking at part 12 here on page 14, should have thought about what polyatomic ions sound like they are to you. I don't expect you to have really seen them before, just thinking about that. Your why, you're going to encounter them in lab and in class. We need to understand how to use them. And then your target, most importantly, is that you can write the formulas and name formulas with polyatomic ions. So first thing is, what is a polyatomic ion in definition? Okay, so we're going to be looking at these polyatomics today. Okay, so what they are is they are a group of atoms, called many atoms to clarify, together with one charge. So that means as a group they have one charge. Okay. So some examples: sulfur and oxygen form some different groupings. So SO4, so one sulfur and four oxygens, has a -2 overall charge. It's called sulfate. Okay. SO3, so three oxygens, one sulfur, has a -2 overall charge. It's called sulfite. And then there's 9 polyatomics that you need to make sure you have memorized, okay, and work with them this year. So they're listed here. So sulfate versus sulfite, there's a difference of 1 oxygen. Ammonium, NH4 is a +1 charge. Nitrate is NO3, -1. Nitrite, NO2, -1. Acetate has carbon, hydrogen, and oxygen, okay. Phosphate, carbonate, and hydroxide. The easiest way to remember the 8 versus 8 is you lose 1 oxygen. So 3 becomes 2. 4 becomes 3. Okay, so if you remember 1, you just remember that 8 has 1 less oxygen. But let's talk about how we write their formulas. We actually do it the same way we just did in part 11. You're going to write out what you have. So in step 1, if we use magnesium phosphate, magnesium symbol is Mg. Then we write the whole polyatomic. So phosphate is on this list right here. It's PO4 with a -3. Second thing, you write the charges for each element. So that would be the metal most of the time. Non-metal occasionally, but Mg is +2. Okay, remember it's in that column. That's +2. If you look back at your periodic table, there's Mg +2. And then you already have the charge written for phosphate. And then you crisscross them. Okay, so we can show with our arrows again, like we were doing before. So if we show with the arrows of them switching their charges, the 3 comes down here, the 2 comes down here. So the 3 becomes from the phosphate down here, 2 from magnesium. So Mg3PO42. Okay, make sure it's the lowest ratio, 3 and 2. We can't do anything to that. It can't be reduced, so we're done. But if it was magnesium and sulfate instead, it'd be +2 -2. You would start with Mg2SO4 but notice 2's are going to get canceled out. Okay, now every single one of these polyatomics I have in parentheses up here because I want to make sure you keep them in parentheses to write the number outside of the parentheses. If there's no parentheses here, it would look like this: Mg3 PO4, you carry the 2 down. Now it looks like there's 42 oxygens instead of 2 of the PO4s. Okay, so that's a big difference. We need to make sure we use those parentheses. Okay. Now naming them is super easy. You just name the metal and then you name the polyatomic. So this is magnesium, that's sulfate. Okay, this is magnesium, this is phosphate. Okay, so naming is pretty easy and people generally find that pretty straightforward. But we're going to practice, okay, both writing and naming, and then you're going to practice. So first one here is NaNO3. So I'm naming it, okay? Na is sodium, right? And I know that. You might still be looking at the periodic table. That's fine, you'll learn. So sodium. NO3, okay? I can come up to this table to help me. I just put one on the same page so you can see it. NO3 is here. It's called nitrate, okay? Just a note about this table too. Do you see how it's just NO3 negative? That means -1. They just didn't write the ones. They're being a little lazy in that table. Okay, this table actually is in the chemistry textbook that we have in the classroom. So that's it. Sodium nitrate, done. The next one, I'm naming it again. Ba is barium. Okay, again, if you don't know, you can look at the periodic table. It's on the far left. Cn, I come back up here and I look. Here it is. So it's called cyanide. So I write cyanide. That's it. Done. Okay. So people find naming polyatomics pretty easy. You don't have to worry about the IDE. Okay. You just have to name them straightforward with the polyatomic. Now let's talk about writing their formulas. Okay, which is similar to what we did in part 11. You just have to watch again with parentheses. So barium chlorate. So barium again is right here. So Ba. You can go back to your periodic table. Barium is right here. So what column is it in? +2. Right? So I'm going to come back here. I'm going to write barium is +2. Chlorate, I come up to this table. Here it is. Okay, so I'm going to write that formula. Again, negative just means -1. Okay, so ClO3 -1. Okay, not a bad idea to just put that in parentheses right now. I'm going to crisscross. So Ba parentheses ClO3 with the 2 after. Again, we need parentheses here. If you didn't put the parentheses, it would look like 32 oxygens, which is not what we have. We have 2 of the chlorines. Okay, that 2 kind of distributes in, so 2 chlorines and 6 oxygens if you think about math class. Okay, but it's done because it's a 1 and a 2. I can't reduce it. Next I have is magnesium acetate, so I'm going to just write that one down here to get myself some more room. Magnesium, again, if you need to reference this, go ahead. Magnesium's here, +2. You'll always get to use the periodic table on a test, okay? So magnesium +2. Acetate, I come up here, it's the first one on the list, okay? So it's C2H3O2. Needs to be in parentheses, okay, just so I don't make sure I don't mess it up when I crisscross my charges, -1. I go ahead and crisscross them to bring them down. So the 1 comes down for magnesium, which I don't need to write. The 2 comes down after the acetate. So Mg, C2H3O2. 2 of them. That 2 from the magnesium came down. Okay? A 1 and a 2, so again, I don't have to reduce, we're fine. Okay? So there it is. That's the final right there. Now, let's get to my last one here, barium sulfate. Barium is +2, as we found out in the barium chlorate. Sulfate, I come up to this table and I look down, there it is. It's SO4 with a -2 charge. The table says 2 negative charge. It's the same thing. I just generally write negative and then the number. Again, not a bad idea to put these in parentheses. I'm going to crisscross, okay? So I get Ba2SO4. But you should stop and say to yourself, okay, it's a 2 and a 2. That feels a little excessive, so I can reduce those, so I want to. So it just becomes BaSO4, and that's it, okay? All right, so I need you to practice. You're going to practice naming. You're going to practice writing, okay? You're going to check your answers because I have your answers posted there, and then I'm going to have you try a mastery check before we move on.